Now please welcome CEO, SLM Solutions, Sam O'Leary.
Hi everybody, and thank you, Harshal. So, if somebody told me when I was an engineering apprentice 20 years ago that today 3D metal printing would be driving manufacturing the way it is, I wouldn't have believed it. To be quite honest, I didn't even know it existed. These were the days when you poured molten metal into a mold made through a complex multi-step process involving dipping into a ceramic slurry before spending hours literally hammering the sand off the cast parts. This was back when some poor dude was spending his days inhaling dust, working with historic equipment and processes in a scene that you might imagine was from the 1800s. But I'm talking about this as if it's over. It's not. This is still a fair representation of much of the world's manufacturing today. But others are choosing something else, something mind-blowing that leads us here to an era where additive manufacturing is pushing industries to create what a few decades ago would have been thought impossible. And it's doing so unprecedented rates, well surpassing the speed and design aspects of which traditional manufacturing methods can handle. On many people's journeys to work this morning, 3D metal printing was at play courtesy of some of our amazing customers. If you were traveling via an electric bus in Italy, it might have had a power line connector that was made by 3DNA. Maybe you arrived by train, and as you pulled into the station, the brake pad could have been built by Webtech. It's possible that the sneering knuckle was imagined by Hirschvogel if you took a cab today, or in a dream world, if life is going well, you jumped into your Porsche or Bugatti, or even private business jet. All of these with parts produced on our equipment. Anything from your new hip to life-saving components used by firefighting teams, 3D printing has really become an essential part of our daily lives. And it's funny because despite all the scars on my hands from the mistakes I made as an apprentice engineer, using all of those old-fashioned machines, today myself and our industry face a different set of challenges to overcome. They are, how can we shift this very cool industry to a place where it uses its full potential to deliver customer success? This is the topic I will discuss today, and I thank you for joining me as we delve into it. To talk about achieving the true potential of additive manufacturing, where we are right now, we have to go back to its humble beginnings. Sometimes I pick the brain of one of our chief engineers, Dieter Schwarzer, a living legend in the additive world and one of the original patent holders of this technology. When he explains what it was like back then, it's crazy to think of how far we've already come. 25 years ago, build envelopes of these systems were tiny, roughly 15 liters in volume. Today, our build envelopes have increased dramatically and can hold a whopping 216 liters. To put this into perspective, let's use the example of something built on one of these machines, the size of a matchbox. If this was done 25 years ago, the matchbox may have taken 24 hours to create. Today, would be created in just a few minutes. The cost of the matchbox, well, to build it back then may have cost between 500 and 1,000 euros. Today, maybe 10 euros. And also, unlike that bygone era, metal 3D printers can be unattended as they pump out production components day after day, week after week. This would have been impossible a couple of decades ago. As you can imagine, this view on additive manufacturing from one of the pioneers of the technology is thrilling. And although it's clear we've already come so far, let's be honest here, there are still significant barriers to overcome for our industry. Despite many people in the industry claiming otherwise, you have to realize that if somebody tells you what is done here in this industry is easy, walk the other way. So thinking of the barriers, the build plate sizes are restricted, the part economics are hard to grasp, the materials are limited, the pre-processing software is a pain in the arse, the post-processing can be difficult. However, in the past years, we have worked tremendously to engineer solutions for these problems, and the results of this work start to become clear. Today, despite obstacles remaining, industries ranging from space and automotive to energy and health realize that the promising world of additive is a solid and future way forward to implement their out-of-the-world ideas while accelerating their visions into reality. Another roadblock is the additive industry itself. Yes, us. Why? Because you will always know your business better than we will. You are the experts. And our current problem in it is we have AM companies that try to create full manufacturing process solutions or a fully integrated factory solution for their customers. Let's get real. We can't go to BMW or Ford and tell them how to automate their production. This doesn't make sense. So when we look at the issues I just talked about, what can we do to solve them? Firstly, we must admit that the current situation is not perfect. The world is not some shiny bullshit Instagram account that we see every day. Nobody has it all fixed. We have to be open and honest about this. During today's talk, I want to talk about some of the companies and key industries that we have successfully enabled to arrive at volume production. Would they look back at the last few years and say, hell, this has been perfect. SLM Solutions has been perfect. Their partners have been perfect. Their machine performance has been perfect. The build preparation software has been perfect. Of course not. At some point, there has to be some acknowledgement that there's a great deal of work to do to get us where we need to be, to get our customers where they need to be, and essentially bringing our customers to a place where they hit epic sweet spots is why we continue to develop today and tomorrow. But first, we must be honest and acknowledge that we can't do it all. What we can do is illustrate that we are trying relentlessly to understand our customers, that every day we are trying to meet our customers' needs in new and unprecedented ways. This is the only way we can get close to ensuring long-lasting customer success. Lately, additive's got a bit of a rock and roll reputation. Soon there'll be a 3D printer on Mars, things like this. But I want to start here on Earth because there is no way that we will affect outer space without first affecting planet Earth in a cool way. So what's happening on Earth? Well, there are millions of people doing extraordinary things, while billions of us need exceptional solutions to the mechanics of daily business. One way additive manufacturing is impacting people's lives is by helping to save them. Take Equinor. In a joint innovation project, we designed and produced an AM firefighter pump with a 70% reduction in weight and increased resistance to seawater corrosion. The lead time was reduced from 20 to only 4 weeks, lowering inventory capital and costs. And if we look at an automotive case, we have to bring up Bugatti and their brake caliper. Volumetrically, this part is the largest functioning titanium component built with selective laser melting. It can cope with extreme strength, stiffness, and temperature requirements. Caliper tests showed a tensile strength of 1,250 newtons per millimeter squared, and also a material density of over 99.7%. We also worked with them to create a heat shield installed in all vehicles since delivery of the first Bugatti Chiron from the production facility in Molsheim. It's also worth mentioning that our proof of concept with Porsche using the SLM Solutions NXG12-600, where we successfully printed a complete e-drive housing with innovative AM design, all the advantages of AM have been implemented in this housing, such as topology optimization with lattice structures to reduce weight, functional integration of cooling channels, higher stiffness, and reduced assembly time by the integration of parts, as well as improvements in part quality. To something a bit more related to normal life. In the transport sector, we have worked with 3DNA using reverse engineering to 3D print trolley heads that connect each bus to the network's aerial power supply lines and mechanically guide rods to the bus's roofs. Today, there are no trolley heads left that have not adopted AM technology cruising around the beautiful city of Naples. And if we take to the skies, our joint project with Safran Landing Systems, where we've successfully implemented our technology to produce a component of a nose of a landing gear for a business jet, a world first for a part of this design, redesigned for metal-based additive manufacturing, additive guaranteed time savings, and a huge 15% weight reduction. From those stories, we are getting solid indications of what we can do for our customers. We see it every day. We see it in the factories of our many customers who operate production fleets. And we see it by looking at the output of those fleets. But we always want to go further and ensure customer success in more ways than the machine themselves. We want to replicate the success of some of our most mature customers and democratize that. This brings us to talking about an additive manufacturing future that is almost at our doorstep. A future where it is more automated than ever before, and it's not a highly skilled process today. Yeah, of course, this is a dream world where everyone gets their kicks thinking about it. It's like both engineers and OEMs want the same. It's not even far away because many of the goals we set for the future, we are already implementing in our current processes. I'm talking about a future of AM where customers don't just have machines, but have an entire ecosystem integrated into day-to-day operations. And how will we continue doing this in the future is by a course of action that extends much further than the mere purchase of a system into an overarching living solution where your systems grow with capabilities and as you grow and develop your visions. And how do we do this? We make it open. In fact, for the future of AM to come to its tremendous potential, it has to be this way. How do we unfold the future using open architecture to get closer to a push and play reality? Firstly, we get there by applying our 25 years of experience and knowledge in everything we do. And again, not just doing this alone, us providing interfaces to the likes of Dyndrite and many others, all of whom can enable more of what our machines can do. Yesterday, I spoke to a customer. It was thrilling. She said, I know how to get more out of your machines than you do. And this is a compelling and motivating statement to hear. And this is because you realize that sharing knowledge enables our customers to do more and allows them to move forward. And in return, it allows us to enable and improve our systems, improve the software, improve the interfaces, and in the end, improve the output and the industry. So if you're an AM company saying, I am the machine manufacturer, I am the forefront of all knowledge, I don't allow anybody to change things, I know best, I don't allow engineers to play, this is a big problem. This is a big problem because you'll never know more than your customer in how best to produce a turbine vane or how best to produce a brake pad for a train. The people who have designed these for years and know the operational conditions, they know how to do that. So when I think about how additive can reach its potential, I believe that we all need to stand up and be brave and say, hey, okay, let's share our knowledge, let's work together, let's get to that place. It's a mutual respect and understanding that will allow us to develop the technology, to continue to develop, and to reach uncharted territories. So this is it. Everybody has to give their input to make it work. And the way we achieve that is by working together, exploiting everybody's knowledge base, exploiting everybody's strengths, and to deliver the ultimate solutions for all of our customers. And yes, in some respects, this is already happening, but in many ways, it still has a way to go. Why? Well, because it's incredibly complicated. There are a million different things to consider. Of course, it's been slowly developing year after year with multiple partners, with software partners, with hardware partners, with automation, working with the FAA, working with a complete broad spectrum of people, powder suppliers, everything needed to make it happen. But there will never be one company that can stand there and say, hey, we did it alone. We enabled additive to reach its potential. It will only happen with companies working together, focusing on the added value that they can have to each part of this very complicated ecosystem. What we can say is this: we're open for business. Let's enable each other. Let's do what it takes. And when I say this, I'm talking about working with partners from the full value chain, because it's what our customers want. It's what the industry needs. By accepting powder from whoever the customer wants to choose, by allowing customized service solutions, by allowing interfaces to all kinds of different software, whether it's build preparation, whether it's ERP system interfaces, this is the flexibility that's needed to move forward. The importance of open architecture is that we are experts in what we do. The customers are experts in what they do, and it is the perfect solution to meet halfway and allow each other to deliver their expertise. These partnerships are much more fruitful than a closed system. For example, in dental AM, implants can now be designed and produced specifically to the patient's anatomy. They enable a more efficient surgical procedure, achieving a functional and cosmetic restoration. The production of patient-matched and custom CMF implants by selective laser melting is more efficient and economical than traditional CNC milling techniques. In medical, patient-specific hip cups made on the SLM 280 are made with a build time of around 30 minutes per part. Here, our customers can achieve the fine details needed across the porous geometry for optimal connection between the implant and the bone to encourage long-term stability of the implant. On top of this, the machine enables the user to control the design of the tunable lattice structure. Traditional plasma spray coating of this processes cannot match this level of control. In automotive, take the example of Divergent 3D. They have a complete production system, an adaptive production system. It's a software and hardware solution designed to replace traditional vehicle manufacturing. They implement our additive manufacturing technology to create an automated manufacturing cell that allows automobiles printed with not just one or two 3D printed components, but several hundred. They can engineer, 3D print, and assemble vehicles while seamlessly moving manufacturing between different models at will. This drastically reduces cost, making the production of vehicles in small batches a profitable reality. In space, SLM Solutions collaborated with Cellcore to create a monolithic thrust chamber, a rocket component that not only has to have a consequent lightweight construction, but must also be able to withstand the exceptionally high stresses. Additionally, the manufacturing costs for their complex geometries are very high when compared to conventional manufacturing processes. In this case, our customer success team developed specific parameters for the geometry to satisfy the aerospace industry's high material requirements, and the engine was manufactured in the nickel-based superalloy Inconel 718 on our SLM 280 equipment. Each industry is unique, and we make sure we can cater for every one of them by customizing our machines for their exact needs, whether it's dental, whether it's space, whether it's using aluminium, whether it's using titanium, whether it's a company like 3DNA, whether it's Bugatti. We're working and we're going to enable as many build visions as possible. Customers will always be reliant on good quality powders, good quality build preparation software, good quality open interfaces to pieces of hardware that run a reliable industrialized software base and hardware base. They are reliant on proper quality assurance methodologies, whether it's in-machine melt pool monitoring or CT scanning afterwards. It's then a matter of industrialization into a factory setting. This could be how us, as a machine manufacturer, provides open connections so that people can connect it to a factory management system. They can visualize factory planning. This is how you enable automation at scale. So how do we create a course for action? Of course, in some ways, we are on course, but the way we wholly achieve it is not by one company or by one piece of technology. Instead, it's a broad ecosystem that leans on the applications of multiple complementary technologies, leading back to the idea of working together by bringing our expertise and your expertise to the table to find solutions. This means partnering up. In turn, this will enable our fundamental goals of doing what it takes to realize the future of delivering what our customers and what the industry needs. Essentially, giving the toolkit to be successful and disrupt your industry as you grow. So what does it mean to disrupt the industry? Well, to start, it's the disruption of traditional supply chains. It's the shaking up of conventional business models. It's the ability to produce 1,000 vehicles instead of 100,000 vehicles and still be within your financial goals. It's the moment in time when you can create just one part, courtesy of AM technology, before moving on to your next brilliant idea. This kind of disruption advances the pace of technologies and advances all of the improvements that we see in the operation of a piece of equipment. Kevin Zinger, CEO of Divergent, said this: technology agnostic, looking at all the current technologies and combining them into new production systems, where AM is one component, the key driver being software, taking a design, running it through all necessary engineering simulation, and then printing that design, meaning you only put material where it's needed, resulting in a lighter, stronger, and durable application than any existing manufacturing technique. I couldn't agree more. And it's incredible that despite the leaps and bounds our industry has made, there are still people in disbelief that AM is not and will not become a mainstream solution. Really? As of right now, SLM solution machines have millions of operational hours of 3D metal printing to create millions of components for some of the most innovative companies in the world. This is on around 700 machines scattered around the globe. Every day this number is growing, and with it the mindset, and the right mindset, that these solutions are just the tip of the iceberg. But what about its potential? Our view is that to achieve it, we all need to be aggressive, and we need to make incremental improvements to this process and to the technology. But I see it differently. The way we get to the true potential of AM is by being experimental, by being flexible, and by being open. We need to come together, share our knowledge, put everything on the table, and use these elements to meet our customers and to satisfy their needs. Anybody can put out a view of what AM is going to be, but there could also be vital technology breakthroughs within our technology field that will change the direction a little bit, kind of like what we did last year with the NXG12-600 when we released it. But to do that, and to disrupt, and to learn, and to grow, and to shake the sector even more wide open, we have to keep making cool stuff, keep working with the best people, keep listening to our customers who know more than we will ever do. And mostly, we need to admit that we don't now, and we never will know everything to succeed. And then, if it's done, what might I say the future of additive looks like? Well, then our journeys to work might be even cooler. They might be filled with cooler additive technology in different types of vehicles. The bus or the train you travel on might even not be a bus or a train. The office you sit in, everything around you, to the Wi-Fi, transmitting satellites, all built with additive. The list goes on and on forever. And in space, we can't forget space, of course. What we build to get there and what we build when we are there will be enabled with the help of additive. So if you're planning on going to Mars and want to make your life a little bit easier for that, get in touch with us about the NXG12-600. So from me, that's what it takes to achieve the true potential of additive and what a team we have with us on our journey to get there. We have the world's best engineers on board, and we're constantly looking for more to join us. We have a permanently open set of positions for those who want to work on cool shit that drives the future. We have a bright day ahead of us in AM. The days of poor engineers working on crappy belt-driven polishing units, inhaling dust all day, they're on the way out, and we can look forward to a new future together with our partners and the people that want to make this happen. A future that is not bound by outdated assembly lines, ridiculous lead times to manufacture a product, absurdly huge production volumes to make things financially feasible, but a future where we are free and are only bound by the limits of our imagination and what we want to design and create. And the most exciting part, it's here right now. That's it from me here in Lübeck, Germany. Thank you for everybody for the time. And most importantly, thank you to Harshal and Dyndrite. It's our pleasure to be involved in your journey. Thank you.